Hi, my name is Aaron Wertz. I'm a senior mechanical and aerospace engineering student at the University of Florida, and in this video I wanted to walk you through one of my senior design projects which involve the design, launch, and optimization of a rocket.
This project was carried out in two phases. The first phase consisted of designing and constructing a rocket to carry a payload to a target altitude of 1,500 feet and return it safely. We chose to name the rocket after the Occupy Wall Street movement that was in the news at the time of our launch and to carry a symbolic payload of monopoly money in paper bonds. As the launch operations specialist on the team, my responsibilities during the stage included constructing the launch pad, painting the vehicle, ensuring proper packing and connection of recovery equipment, interfacing the vehicle with the launch pad, and preparing and installing ignition charges for our H-class solid rocket motor.
Here's our launch viewed from the ground. And here's the view from the onboard downward-facing camera. Several aspects of the launch did not go according to plan. An underweight payload caused the rocket to over-accelerate and spin, and ultimately overshoot our target altitude. In addition, oversanding the nose cone to ensure parachute deployment resulted in our parachute slipping out prematurely. Ultimately, the rocket had a stable flight and returned the payload safely to the ground. I've attached several documents to this application package, including my team's final launch report. In this report, I wrote sections 5 and 6, which detail the flight performance of the rocket and explain why it behaved the way it did in the video that you just saw. In the second phase of this project, we numerically optimized the baseline design you just saw fly to attain a maximum altitude and to carry a maximum payload weight. In order to do this, we split up several different optimization parameters amongst the team. I chose thrust and root chord and looked at these relationships between each other. I used RockSim to simulate several launches and generate data sets, which I then analyzed in MATLAB to find the optimization patterns between the data. This is detailed in my individual report, which is also attached to this application package. After we determined these parameters individually, we then combined all of them to determine the overall optimal rocket designs. And this is something that you can see in the PowerPoint presentation I have attached to this application package. My primary role in this was to look at all the optimization data generated by my team members and disseminate the data in order to determine a four-dimensional design space for our optimal rocket and find the optimal rocket within that design space. I just wanted to say thank you very much for considering me for this opportunity, and please feel free to contact me if you have any questions about my experiences or qualifications. Thank you again for your time, and I look forward to hearing from you.